So this is a real example from one of our customers. This is an automotive part. It's an assembly tool. It's kind of like a rack. And with the standard slice that they started off with, they have a concentric infill, they have outer walls, everything looks normal. We can turn on our solid bead view, and we can see there are a couple gaps. So based on this pattern here, or the concentric pattern, there's gaps. And then because of the differences in radii here, we have gaps here as well. So this is what a standard slicer would kind of output, but really they need something that is solid, completely solid. So we're going to optimize this bit by bit. We can filter out different areas, so different boundaries. So we filter outer boundary, and we can get the inverse of that filter. Then we can filter by line type, so we can filter filters, so we can keep going until we get the area that we need. And for the infill, we can apply a curvature compensation. For the outer wall, we can apply a curvature compensation. So what this curvature compensation does is it applies this little kink here based off the settings that you provide. So we can see the before and after, So it analyzes where the curves are, and it can push them outwards. So that has solved one of those issues by closing off these gaps. But we still need to do more for the infill here. We also applied a curvature compensation for the infill, so it's pushed in a bit further. We can use our optimize operator to analyze for curvature like we did before. So you can see it will highlight all of the different corners of the part, and we can apply thickness multipliers here. But we want to be more targeted than this. Because
what you said now, like in the corner we are seeing on the first move you did, it moved it inwards. But with the optimize, you can bring that back, as you showed before, with the speed to the actual fillet. So still close the gap, but still retain the border.
Yeah. We also have these particular problem areas here, like I showed before. So I want to find a way to get these corners, but without getting the right angles, because these right angles are perfectly fine. I don't want to increase the extrusion here, but we can do that very easily. So I've used a filter to isolate on every layer this particular polyline here. This is the one where we've got these large kinks in. And then I can perform a curvature analysis. So it's analyzing our corners, our curves and turns. And then I can actually filter with that data. So I don't want the right angle, the sharp 90-degree turns. I want these, which are actually less than 90 degrees. So I'm filtering 0 to 89 degrees. And we can see that the output of this, it's taken out our right angles. So the inverse of this filter, of course, all our little right angles. And this is all taken out. And now we can do our thickness optimization here. So I can double the thickness of these particular areas and our polylines with the solid view. We've closed off these gaps now. So they are solid and dense. We've left the right angles perfectly untouched. And we can combine all these things together and see the fruits of our labor. It is now a wonderfully dense component. We can go even further. I showed you the make continuous before that combined those two outer walls, but it's way more powerful than that. At this stage, we can see our seams. So we have one for all the outer walls, one for all the infill, one for all these like boundaries in here. After our make continuous, it's going to make it a single start and stop for every layer. So we can see, and it's still perfectly dense, which is just fantastic. We can also just shift our seams along so that they're not on that tight corner, so we can keep it nice and neat. We can add a brim to make sure that it's nice and solid to the base. And then we can also filter the first layer, slow it down by half, because often the first layer you need to go slower. So we can easily do that. And combine the whole thing together to have our wonderful print. And we can, of course, go ahead and do the toolpath of that. And to make sure that our speeds are all as we want them, there's also a thermal simulation to validate that everything is grand. And I believe it should all be green. Yeah.
Nice.